Right, welcome back. Found a horrible question. Actually, not a horrible question. It's actually not too bad. It's actually a nice excellence question, to be honest. Newton's law of cooling. No, not cooling, just Newton's law. Oh, no, not even Newton's law. Right, let me just make this. Setting up the question, folks. Just give me a second. Right, so this is the next question that we're going to be looking at. Yeah, it's I was actually surprised to see this question pop up, because this was it looks horrible, but the reality is it's actually really kind of a nice question to go with. Like I'll be honest, Newton's, like, these questions with the direct proportional questions, they are what I call the standard bread and butter question. Like, they usually have like some sort of formula that you have to do differential equation for, and then you got to find the k value, and then once you find the k value, you substitute the new t value and find out what it is. I call it a bread and butter question, because if you get any of these types of questions, there is a repeat pattern that happens all the time, and you end up getting an easy E for these types of questions. By the way, we're only going to do one integration excellence question, guys, because I've got a few things that I need to do soon. So yes, I believe it is there, bus driver, because when did we do it? No, not trapezium. Ugh. There we go. It is part 14 is the one that when we did part 14 and 13, I think. Yeah, 13 we did definite integrals, and then we did some exam questions with 13, and also part 14, Newton's law of cooling. So today we're looking at this question here. I think it's 14, bus driver. So I'll give you folks maybe about 4 minutes, because I think this, as I said to you, bread and butter excellence question. 4 to 5 minutes to try and do this, and then what I'll do is I will actually go through the answers, and then we'll figure it out together. I was trying to do one question a night for excellence, but somehow we always get distracted and do two. Last night I did two, and I was like, by the time I got to bed, I was just like seeing a whole bunch of differentiation in my head. Shooter, I'm the worst person that should be giving careers advice. You look at me, I'm a full-time teacher. I do YouTube in the nighttime, and then I have my own laser cutting business on the side, and I work so hard and I make no money. So I think I'm the worst person to ask for careers advice. That's all I'm going to say. But what I will tell you, Shooter, is this. While I might not be rich, I'm genuinely happy, man, and I think that's, for me, it's much more important than having a lot of money. Thanks, Thomas. Yeah, so it's ln of y there, Jot. Lauren, eh? 5 minutes and she's done. Shot Lauren. Is Blake gone for the day, or has he gone off? Yeah, you're on the money, Lauren. That's it. I got a 195 here. Oh, 195.9. Yeah, no, you're on the money there. Jot, it'll always be y equals AE KT. All right, so let's actually go through this question. All right, now look, it says it's directly proportional, which means, again, I think I did this in the part 13, was it, or 12? There we go. I did do it in part 12. No, I didn't. I think I just jumped in straight into this. But anyway, let's go through this. So what we've got is we're going to start off with fluid starts with viscosity. So we're going to put V is equal to viscosity. And then T is going to be for time. And what we've got is dV dt is kV. All right, this is your, when it says directly proportional, this is what we kind of start off with. Now, once you do this, this is no different to the question we just did earlier today for the merit. If I was to break this question down, like if you look at it, right, it says starts with a viscosity of 7.8. That means when T equals to 0, the viscosity equals 7.8. After 1.8 milliseconds, is it? Yeah, milliseconds. So when T is equal to 1.8, the viscosity is equal to 982. And then when T is equal to 1.2, what is the viscosity? That's what the question is actually asking us to do. But we have got all the information that we need. So to do this, we are going to get rid of the, what are we going to get rid of? Get rid of the V first. So we're going to get dV over V equals kT. Then we're going to integrate both of these things, and we're going to get ln of V equals kT plus C. And then we're going to get V is equal to EKT plus C. Now, remember that C is a constant. So if C is a constant, we're going to get e to the power of C, e to the power of KT. Then your V could be written as AEKT. And I think this is what, Jot, you were actually talking about. Now, in this exam, you've got to set up the DE. Like this particular part here, this entire part is like, every time you do this question, you do this part all the time in the yellow box. It's like it's a given. All right. What you can't do, and this is something that you have to be careful of, you can't just jump from this line to this line in one shot. You can't do that, because you want to make sure that you show the working. All right. If you do the direct jump, they'll kind of go, oh, I don't know, this guy just made up stuff. So really important that you show this particular work, and they'll have different letters, but the concept is always going to be the same. That's in the yellow box. Now, once you do that, then it is, we go to T is equal to 0, V is equal to 7.8. Now, I already know that the A value is going to be 7.8, because generally speaking, the A value is the starting point. So in here, we already can see that T is equal to 0 and V is 7.8. So I already know that, but I still want to prove it. So 7.8 is equal to A E K times 0. 7.8 is equal to A times e to the power of 0. 7.8 is equal to A times 1. So A is equal to 7.8. Next, I do T is equal to 1.8. V is equal to 982. So I'm going to get 982 equals 7.8 EK times 1.8. So what I will do is I might just pause here for a second, and I might get you guys to try this question out for the rest of the parts. But figure out what K is. Once you figure out what K is, then just do the next part, which is put T equals 1.2 and figure out what the viscosity is. Yeah, Devin's on the money there. It's like they change the context. Like if I look back at, what is it, 2023, do they have it? Yep, 2023 they had it. 2022, did they have it? We'll go through and I'll show you guys if they, for every year that they've had it, this particular type of question. No, 2022 they didn't have it. 21. Yep, 21 they had it. Melody, because as I said before, C is a constant. When C is a number and you put e to the power of any number, it's just going to become another number. So I mean, you can call it A, you can call it any letter you want, but it's still going to be a constant. E to the power of C is still going to be a constant. Can you just find the plus C value by subbing 0 in? Yeah, you could do that as well, but I think what you want is, I think you ideally want the A value there. Eric, I hope I answered that question correctly. Oh, it's all right. All right, so let me just finish this question off. So 982. So I'm going to 982 divided by 7.8 is e to the power of 1.8k. Take ln of both sides. 982 divided by 7.8 equals 1.8k. K is equal to 9 ln of 928 over 7.8 divided by 1.8. So k is going to equal whatever that is, which in this case we've got ln of 982. Thank you, I made that same mistake as Satvik. Thanks, Satvik. So 982 divided by, what is it, 7.8, close brackets. No, I would like to divide all of, no, you know what, I'm going to put this like that, divided by 1.8. So I should get k is equal to 2.6863. Now I'm not going to get rid of the k from the calculator, because when t equals to 1.2, viscosity is what? So we're going to go viscosity equals A, which is 7.8, e to the power of 2.686 times 1.2. So I'm just going to multiply this by 1.2. So that's going to be e, so 7.8 multiplied by e to the power of this answer, which is going to give me 195.93. So pretty much excellence E8 right there. Can we just plug in the system of equations into calc to find A and K? Yeah, I see what you're trying to do. You can have a who is this? Who is this? Who is it? Who asked that? I missed that. I saw the question. Devin. Yeah, I know what you're trying to do. You're trying to create a simultaneous equations. Yep, that would work. But I would still show some sort of working that you're doing simultaneous equations. The key thing is, like with excellence questions, you don't want to miss out grades, because just show the basic amount of working. Yeah, yeah. I mean, like, you could do that as well, Cujo. There's multiple ways to do this question. The thing is, sometimes you will get a simultaneous one, but I think the only time you get a simultaneous one is when they don't give you the starting value of 7.8. Like, they won't tell you the starting value. But going back, like, if you have a look at the last few years worth of papers, this was where was this? This was 2023, I think. Did we have one? Yeah, so 2023, there was a question there in 2023, and I think that's the last year's one. They didn't actually give you t equals to 0, So they gave you t equals to 1 and t equals to 2, and then you had to use simultaneous equations to try and solve that. So every year it does kind of pop up. What's this one? Oh, this is a similar one. Yeah, this is another similar one, but a bit more work. 2021. There we go. Water tank develop a leak, and you've got the usual suspect, right? This one again, they didn't give you t when t equals to 0. Like if you look at it, the last 2 years they've given questions where they're not giving you t equals to 0, so you can't get that a value straight away. Instead, you have to create like a set of simultaneous equations to try and solve it. What about 2020? They have in 2020 dy dx. Oh yeah, 2020 as well. Here's your bread and butter question. You can kind of see. So they've actually given you the differential equation, and then you kind of try and work it out. So yeah, now folks, that's pretty much it for today, because I just wanted to do that one quick question. I've got a big week ahead at school, so I've got to do a bit more planning for school. Will you ever have to solve for k first, then a? Yeah, well, I mean, I think it depends on the question, right? Like if you get a question where, hang on, like if you get a question where you given like multiple things, then yeah, you might need to use simultaneous equations to figure both k and the a value. No, I don't have like I'm mindful of like some schools still haven't done that. So yeah, I'm not sure. I haven't actually had a look at it. What is it? Where are you? Jot, I think this is my schedule at the moment. As you can see, I'm pretty much doing not complex numbers. I'm doing an excellence question every night with the level 3s, but it'll just be one excellence question because it gets pretty intense. But I'll leave the link there. I think we've got complex numbers excellence tomorrow, and then differentiation on Thursday. Yeah, so we do one excellence question every night leading up to the exams. Level 3 doesn't happen until 11th of November, and I think I'm doing maybe one more help desk. But we'll mainly do excellence questions, because I think excellence questions is like good because it kind of covers the they're all right, Jot. I mean, I know like they had I think they've kind of repeated the same questions again from previously, so you know, eventually they like those questions, unless they come up with questions later, it's kind of similar, right? Yeah, true, Jot. But the thing is, like when you do excellence question, like sometimes you can answer like 2 lines in an excellence question, you might get a merit for it. No worries, Devin. You're welcome. Level 2 maths is on 5th of November. Yeah. It's good fun, the whole thing. Doesn't change. Yeah, have a good one, professional. Yeah, they're good, Jot. Like Jot, I would like at the moment, if you need practice, I think I would go for it. Get as much practice as you can. And doing all of these questions will help you. Like all these achieved questions and merit questions definitely help you with getting that sound knowledge to get excellence. Emmanuel, I don't know if it's public. Are those papers public, or is it like only certain people can access them? Yeah, I thought he was, but he keeps he sometimes he comes in and then he disappears. Junior college, yes. Junior college is where I'm at. That's where don't have to mark any of these big NCA papers. All right. Maybe it's time. What is it? Huh. Where are you going now, Jot? Head prefect interview. You shouldn't ask me because I failed it twice. The other one is ourexams.org. Satwik. That's a good one as well. But study time covers only NZQA papers, right? Ah, 9:24. Is it too late for warehouse? Something's not right. I'm missing something. Oh no! I was supposed to buy this thing on TradeMe. I think I've just lost it. Ooh, $41. It's too much. I am not paying $41 for that. No worries. You're welcome, Epiphany. Look, guys. Look, I'm pretty much done here. I am. By the way, if you're down at Wellington, I'm gonna be coming this Saturday. I don't know. I thought I'll come and have a chat with some of you, but we'll see. If not, I'll just head to the city and have a cup of coffee. Yeah, but the other one is where is it? Tauranga. I'm coming in November 15th. So if you're around, yeah, look, let me know. Nice, Cujo. I'm glad you like it. Ishnan, I'm coming November 15th for a conference there. I'm presenting, and I think we're looking at organizing a room if whether you guys could actually come in and have a sit down during the conference. So the conference organizer said that we can probably organize a room for the students to come and just kind of have a chat. But yeah, it'll definitely be at the Waikato University campus in Tauranga. So yeah, so that's where it'll be held, the conference. There'll be a whole bunch of maths teachers there. All right, guys. Anyway, take care. I'm gonna go get some shut-eye and got an early start tomorrow for work. Yes, we're done, but we'll see you tomorrow. I'm new here. What exam are you guys preparing? Long. We were doing some we were doing integration excellence question, but we're done. You've been very quiet, TJ. How you been, man? Nah, you're welcome, TJ. It's all good. You know, I haven't even got a hoodie for myself. My wife has one, but I don't have one. I need to make one for me. I think I've made too many things, so. Okay, folks, take care. I will see you tomorrow for complex numbers. Excellence question tomorrow. Should be a bit more fun, eh? All right, take care, guys. Catch you later.